Hey guys, how's it going? It's Ben from Chegg Tutors here, and today we'll be covering the statistics concepts of outliers and influential points. So in this video, where we're going to first define what outliers and influential points are, then we're going to discuss some similarities and differences, and then we're going to go over some examples of how to differentiate and distinguish between these two kinds of points on plots. So, outliers and influential points are terms that you may have heard or thrown around, but not really known what exactly they mean. So hopefully this video will clarify between these two concepts for you. So, onto the definitions. An outlier. So for both of these we're going to be talking about a general XY plot, where you're plotting something like the independent variable and the dependent variable. And we'll still stick to generally like linear patterns. So linear regressions, for example. So an outlier is a point on this linear regression plot that diverges from the pattern. So it doesn't follow the overall linear pattern if there is one. So for example, if we look at this plot and we draw in red this point over here, you can see that this point doesn't really follow this linear pattern established by all the other points. So we can call it an outlier. So let's go over some other attributes of this outlier. Outliers generally have large residuals. So recall that a residual on a linear regression is the difference between the actual y value of a point. So over here, the y value is around 2.4, and the predicted y value of the regression line, the least square regression line. So that'd be around here, and it'd be around like 1.2 to 1.3. So this difference here will be our residual. So this is pretty large compared to the residuals of all the other points that are generally along this least square regression line. So large residuals generally indicate an outlier because it indicates that the point is far removed from the line pattern. And outliers also lower the significance of the models. So what does this mean? The significance of the model is determined by, the higher significance the better. So it's determined by how closely your points on your plot fit your proposed pattern. So in this case, the proposed pattern is the least square regression line that runs between the lines. And the better these points fit your model, the higher your significance is, and the better you can use it to predict further things based on that model. So the fact that we have this outlier is going to lower the significance of our model. And the reason behind this is because having this point all the way out here means that maybe our linear prediction isn't so accurate after all. If we have this, maybe there can be other outliers, and maybe this line isn't that good of a fit. So those are outliers. Now let's talk about influential points. Let me erase this. Right. So influential points are, their names are pretty accurate. An influential point is a point on the plot that has a large effect on the regression line slope. So this line over here, if it's a point that has a large effect on the slope of this line, then it's an influential point. So that's a pretty roundabout definition. So how do we actually determine whether or not something is an influential point? Because it's pretty easy to determine if something's an outlier. All you have to do is kind of eyeball it. We saw that the red point was all the way up here. But yeah, it's pretty far away from the rest of the points. But for an influential points, the standard way of deciding whether or not it's an influential point is to first, so let's draw. So let's say that we're trying to decide if this over here is an influential point. The first step is to remove this influential point from the plot, and then plot your least square regression line. So this is already done for us. So this is our default least square regression line without our influential point our point that we think may be an influential point. The second step is to then replot your influential point. Oh, let's make it red again. And then this time recalculate the least square regression line. So in this case, this may look something like this. Something like that. So the way you tell if the if your point is an influential point is you plot the least square regression line with and without this point, and if there's a major difference between the slopes, then your point is influential. So in this case, this red line is the slope of our least least squares regression line with the point, and then without the point, it increases drastically. So we can say with confidence that this point is indeed an influential point because it influences the value of the slope of our least square regression line. So these influential points are generally extreme values, and generally influential points are usually outliers, but the opposite is not true. Outliers are not always influential points. So to drive this point home, let's do a few examples and see how this can be true. So let's first look at an example of an outlier. So let's say we have this line. So an outlier would, as we said, look something like this. So this is an outlier. Now, if we want to test whether or not it's an influential point, we just follow that example, our previous example. We first remove it. And so let's say once we removed it, we get this line. So this is our least square regression line of the data points. So you can't see all the other points, but just imagine that they're there. And this least square regression line is right here. So this is without the point. And let's say we add back our point in red. We add back our point that we're investigating, that we already know is an outlier, but we're not sure if it's an influential point. And we draw the new slope, the new regression line, and it's something like this. So, as you can see, the slope didn't really change that much. There's a little shift up because of how how high on the plot, how large the residual is, but there's not that much of a difference. So we can say that this is just an outlier. It's not an influential point. On the other hand, let's look at this plot. Let's look at a similar plot. And this time our point is all the way over here. So once again, we can visually identify that this is an outlier because we see the large residual and how far away it is from the rest of the data. And to determine whether or not it's an influential point, we can just put it off, and we can say that this is the least square regression line without our point in question. And when we add it back in, we replot the regression line, and we get something like this. So this time, the shift in slope is huge. So we can call this an influential point, because once again, the removing of the influential point significantly changes the slope. It increases the slope significantly. Whereas here, with just this regular outlier that is less extreme, it doesn't influence the slope that much. So, in general, you can say that influential points are super extreme outliers. They're like outliers that are super away from your trend line. And to finish off this video, let's look at a point that some people usually get confused with these two concepts. So let's say we have this least square regression line again, and the point that we're going to be looking at, actually for this one I'm going to actually draw some points to make a point. So let's say we have something like this. These follow generally a line and then a point all the way over here. So a lot of people get confused with this kind of problem. They're like, well, this is an outlier, influential point, or neither. And so let's look at our definitions again. Remember that the definition of outlier is something that does not follow the general pattern. And for this point over here, we can say that it does indeed follow the general pattern, because although it is far away from all the other data points, it follows the general line of the data. Oh, that's pretty big. Let's make it thinner. So it's pretty close to like the least square regression line that you already get from this data set. So although it's so far removed from the rest of the data points, it still follows the general pattern. So we can say that it's not an outlier. So what about the influential point? Is it an influential point? So we follow our process for determining that. And the first thing, my camera's covering this up. Sorry about that, guys. So let's say that the point in question is over here. There. Alright, that's better. Okay, so this is our point in question. and we see that even though it's kind of far away from the rest of the data, it's still within the realms of the overall pattern. So we already identified it as not an outlier. So to see whether or not it's an influential point, we just follow the same steps. So let's say that this is our least square regression line with the point in question. So when we take it out, we see that it remains pretty much the same. We don't even have to redraw it. It's pretty much the same. So remember our definition. Our definition says that if we remove the point and it has a big effect on the slope of the regression line, then we can say that it's an influential point. In this case, it had virtually no effect on the slope of the regression line. So we can say that it is also not an influential point. Even though, let's draw that, even though it looked like it might have a large effect because it's like so far away from the rest of the data. But that's not the case. So this point over here, this far extreme point, is an example of a point that is neither an outlier nor an influential point, but that the professor might try to trick you with because it looks so far away from the rest of the data. Okay, so that was outliers and influential points and the differences and similarities between them. And I hope that now you are a little clearer on how these statistics concepts can be applied to plots.